Okay, so what we are doing is we are doing our lesson on combining transformations. So again, this is going to be in your note package, and then we will also be doing the 2 lessons in the workbook as well. What this is, it is putting everything together. Okay, so everything that we've learned in the first 6 lessons, that is all going to now go into this lesson. So we learned things piecemeal. So basically I taught you the translations first, and then we did reflections, and then we did stretches. This here is the final equation, what you would get once all transformations are done. So it looks really scary, but we'll be doing this, writing this so many times that you'll actually see it's not bad. So the first class we did the horizontal translation, which was the H parameter. So remember, that was your horizontal translation. And we did the vertical translation. So the K parameter was the up and down. Then we did reflections and stretches. So the A parameter was your vertical stretch, and it was a vertical reflection. That was your A parameter. And then your B parameter, that was your horizontal stretch. And if B was negative, that would be a horizontal reflection. So this is what the equation looks like after a function has undergone all 4 transformations. This is what you would get. Now, from here, I want to show you what your mapping is. So this is what the mapping is going to become. And again, this is going to look like daunting at first, but you will do it so often it won't be bad. When you have a coordinate, x comma y, what you do to your x's is, yesterday we were dividing x by b, right? And the first lesson, we were saying x plus h, because remember that the h and the b parameter, they affect your x coordinates. The mapping for y is a times y plus k. So this is going to be your full mapping. This is not provided on your formula sheet, so you'll have to memorize this. This one up here, it is provided on your formula sheet. Okay, what happens is, remember when we have an original point, the new point, this guy is x prime. And then when you have your original y, and I say the transformed y, that new point would become y prime. Now, there's another way I could sort of write this, and the other way that I could write this, so we're going to do this mapping almost with every question. One of the questions, though, I'm going to use this. I'm going to say x prime is equal to, and what x prime would be equal to is the original x over b plus h. And then the other one, if I said y prime, so what's the new transformed y coordinate? It would be a times the original y. This is your original y, so ay plus k. So just sort of have these 2 separate as well, though you will be doing this a lot over and over. Okay, from here, we have to know about the order of transformations. So when I give you all of those transformations combined, is there an order? And there is an order. The order that we do transformations in is SRT. So SRT is, we always take care of stretches first, then we take care of reflection second, and then last is translations. So I tell my students, like, in order to remember this SRT, when you wake up in the morning, the first thing you do is stretch. Then you're going to reflect what you're going to wear to school, and then you translate yourself to school. So SRT is the order that we undergo transformations. This, though, this mapping, it takes care of SRT. So if you understand how to map, then you don't have to apply SRT. The mapping will do it for you. There's actually 2 different methods to teach this. I teach this by mapping, and then when I have my new graph, I have 1 graph. Mrs. Stevenson, for example, she teaches SRT. So when the students are given an original graph, she makes them first graph the stretches, and then she makes them graph the reflections, and then she makes them graph the translations. I consider that more work. I just teach mapping, and she doesn't teach mapping, right? So it just depends on which each teacher prefers. Okay, so let's sort of look at this. And what it says is describe how the graph of each function below is related to the graph of y is equal to f of x. So first thing you have to be able to do is we had 4 parameters. We had h, k, a, and b. You have to be able to look at this and you have to be able to take out what each parameter is. So many of you will be able to see this and will be able to say, okay, that's your k parameter, right? So k is equal to -5, because remember you visualize your k over on the right-hand side. That's your k parameter. This parameter here in front of f of x, that is always going to be your a. So the a is equal to -2. Now, if I was to describe these two, I do want to describe it talking about the stretches first, the reflection second, and the translations last. So if I was to describe this, I would have to start with my a value, okay? And the a value is a vertical stretch. So I would say a vertical stretch, and then I would say what the stretch factor is. So vertical stretch, stretch factor is equal to, it's always the absolute value of a, so there's a stretch factor of 2. Then I'm going to take care of the negative. So after stretches, I would take care of reflection second. This was a vertical stretch, and remember if a is negative, it's a vertical reflection. So the second thing that happens here is there's a vertical reflection. Remember that a vertical reflection is your up-down reflection, and you're cutting the x-axis. With reflections, you have to tell me what axes you're cutting. So it's a vertical reflection in the x-axis. Okay, the last thing that we would talk about for this is the translation. This is the translation, it's your k value. K value, remember, was your vertical translation. So this would be a vertical translation, 5 units. And then you tell me the direction, and the direction would be down. See if you're able to take out the 2 parameters for this. What is this guy? Which parameter is that? And what parameter is that? This parameter here is within the function and is next to x. That is your h parameter. The h parameter here is going to be 4. It's going to be a horizontal translation 4 units to the right. This is your b parameter, right? So b is equal to 3. We know that this is going to be my horizontal translation, and this one is going to be my horizontal stretch. So I'm just going to write that. If I had to talk about the order now, you do your stretches first. So the first thing I'm going to talk about is this, right? So I'm going to say this is a horizontal stretch. Stretch factor of B is always the reciprocal, or the stretch factor is always the reciprocal of the B value. So stretch factor of 1/3. I've talked about this now. So now I'm going to do the last translation, which is going to be this guy. This is a horizontal translation, 4 units to the right. Okay. Let's see what this mapping will look like. Given this graph, it says, here's the graph of y is equal to f of x. Sketch the graph of, and this is the transformed graph. Now, we do not have to do SRT if you know how to map. So let's just write what the mapping is. Actually, before we do that, no, let's write all of our parameters. So could you please take, look at this, look at the original equation if you need to, and then write what the parameter is. So what parameter would this be? What would this 2 be? And what would this be? That's the first thing you have to be able to do. This guy right here is your k parameter, and k is 1 if it's on the right-hand side. This is your b parameter. It is within the function of f of x, right? It's within the function of f of x, and that is going to be my b parameter. This here is my h parameter, and that would be -3. if I said, well, what's your A value? The A is in front of the function, and there's an invisible 1 there. I don't need to write the 1 though. Or I don't need to write A is equal to 1. So there's actually 3 transformations happening. There's going to be a stretch, a horizontal stretch, and there's going to be 2 translations. Okay, write your coordinate, x comma y, and here's what the mapping is. X over b plus h. And then your y's, it's a times y plus k. So now let's redo this mapping and let's write in our parameters. X, y, where that will go is x over b. So x over 2 plus h. So plus -3 is going to be the same thing as -3. A times y, A is just 1, right? I don't need to write 1 times y. So I'm just going to write y plus k. K is 1. This would be your mapping. Now we could map all of these points. So let's take this first point, and I'm going to call that guy A prime. It is at, A. It is at -6 and 4. -6, comma 4. It would be -6 divided by 2 minus 3, and then 4 plus 1. -6 divided by 2 is -3. -3 minus 3 is -6. And 5. 4 plus 1 is 5. That is A prime. Let's do this point. So let's call this B, -2, comma 4. Where that point is going to go, -2 divided by 2, minus 3, y plus 1, which would be 4 plus 1. This point is going to be my B prime. That would be -1 minus 3, so that's -4, comma 5. See if you could get C and C prime and D prime. So C is at 0, -2, and D is at 2, comma 3. C prime and D prime. Okay, if you did this correctly, your C prime should be, let's see, 0 divided by 2 is 0 minus 3. So it should be -3, -1. That should be your C prime. And then 2 divided by 2 is 1 minus 3. This guy should be -2 and 4. So now I'm going to map all these new coordinates. So A prime is at -6, comma 5. Going to be right here. B prime is at -4, comma 5. C prime is at -3, -1. And D prime was at -2 and 4. So -2 and 4, that would be your D prime. You would take your ruler and your pen and go from A to B, B to C, and C to D. So this red graph that I have, that is the transformed graph. That graph actually underwent 3 transformations, right? So the 3 transformations, it underwent a stretch, and then it underwent a horizontal translation and a vertical translation. But I only did 1 picture because I decided to map my coordinates. If I don't map the coordinates, you'd be taking each point, and first you do the stretch, and then you would move it left or right, and then up or down. right? So I find just mapping is going to be the most efficient way. Let's look at this example. So again, very similar to what we did in the second example, except this B we are going to star. Because something's going to happen here. Okay, this one should be simple. There's only two parameters. See if you could figure out what parameter that is and what parameter that is. So write those two. This is an A parameter, and A is 2. That's going to be a vertical stretch. This is my K parameter. K is equal to -3, and that's the up-down move, so that is a vertical translation. When it says describe, that's where we have to go in the order SRT. So in this one, I'm going to start with my A parameter, and it's all I have to say is what is it and what's the stretch factor. So this was a vertical stretch factor of 2. Then there's no reflection, so I'm just going to go to my translation. There was a vertical translation in this, and it is 3 units down. So K is equal to -3 is a vertical translation, 3 units down. Okay, this one here, the reason why we star this is because how it sort of needs to look over here. Students might look at this and might say that's your B value, and you would be correct. The B value is 1/2. The H value, it looks like the H value would be 2 here, and it is not 2. Here's the reason why. When you have your function, it's the B parameter needs to be factored out, and then it was X minus H. Right, so on that first page when I gave you all of the transformations together, you must always factor out the B. And in this case, it's not factored out. So let's just write down and star that. You must always factor out B. Factor out B. Okay, so I'm going to be dividing each of these by 1/2 is essentially what I'm doing. Y is equal to F of, I just factored out that B, okay? This would leave me 1/2 divided by 1/2 is just X. So essentially you want X by itself, and then minus 2 divided by 1/2 is the same thing as 2 times the reciprocal of this, which is going to be 4. So this is actually going to be a 4. When your B parameter is factored out, now we could get the parameters. So this is your B parameter, and B is 1/2. We know that B is a horizontal stretch. This is a horizontal translation. That's going to be my H parameter. H is going to be equal to 4. So that's why I was saying, if you were doing this question, you forgot to factor out the B, you would get the stretch right, but you would have, students would tell me if they forget to factor out, they'd say it's a horizontal translation 2 units to the right, and they'd get it wrong, right? So they'd only get half marks for this question. Okay, so if I was describing, I'm going to do the stretch first. So horizontal stretch factor of reciprocal of B is 2. This, number 2, would be horizontal translation 4 units to the right. So those are the 2 transformations. I will be giving you several more examples where the B value is not factored out. And the reason why they do that, or we do that, is because on the diploma, they will never factor out the B value. So on your exam, when we talk about the exam tomorrow, the B value will not be factored out. You'll have to factor it. Okay, let's look at one last question, and then we'll go to, I think there's only 1 or 2 questions in the workbook for this lesson. So what it says here is it says a transformation of the graph of y is equal to f of x is represented by this equation here. So maybe let's just write down y is equal to f of x. That's my original. And this will always be your transformed equation. So y minus 1 is equal to -2 f of, I'm going to show you, this sort of looks messy, but I'm going to show you what this really is. X plus 5. Actually, I'm going to show you that right now. If ever you see a 3 or a number in the denominator, if you put this x plus 5 in a bracket, you would say there's really an invisible 1 in front of your bracket. 1 over 3, that is going to be your b value. And then I have this x plus 5. So again, that's 3. You sort of move it, put your numerator in a bracket, and that's really 1/3. So what I could do is I could distribute in this 1/3 if I want to, but I'm not going to because we always factor out the b. Here the b value is factored out. Okay, so from here, can you please write all of your parameters below? So there's an h in here, there's a k, there's an a, and there's a b. All parameters are there. So just right below this, write out what all the parameters are. And I just always write from left to right. That is my k, and k is 1 if it was over here. This is my b, b is -2. So there was a stretch and a reflection. Horizontal stretch, horizontal reflection. Oh, sorry, that's not b, that's a. That's my a parameter. That is a vertical stretch and a vertical reflection. Would be this guy. Here's my horizontal. So that is my b parameter. B is equal to 1/3. This guy is my h parameter. And h is equal to -5. So it's going to go 5 to the left. So these are the four transformations are happening in this. Actually, more than 4. There's actually 5 because there's a reflection as well. So there'd actually be 5 different transformations. Then it says the 0.75 lies on the image graph. So you have to say, where does 7.5 go? Is it here or is it here? If they say it's on the image graph, remember that's always the transformed graph. So 7.5 goes here. And what they want is, it says, well, what is the coordinates of the corresponding point on the regular graph? So they want this guy. So you might be like, okay, last time we did this in the first lesson, we went backwards, right? It's going to be a lot of work going backwards. If you remember the mapping, you will be able to get it. So remember that this point here is x prime. This point here is y prime. From the mapping, remember that x prime, how we got the x prime, it's always x divided by b plus h, right? That's how we get our new x prime coordinate. I know what x prime is though. X prime is 7. So I'm going to take 7. I'm going to put it in for x prime. I don't know what the original x is. That would be this guy here. So x over b. Now, x divided by 1/3, that is the same thing as 3x. So hopefully you see that. So x divided by 1/3 is the same thing as 3x. And then plus h, that would be plus -5, which would be -5. And then you'd have to solve for x. So add 5 to both sides. And you would get 12 is equal to 3x. Divide both sides by 3, and you're going to get x is equal to 4. This original coordinate is 4. To figure out y, you have to say, what was that formula for y prime? So in order to get your new transformed y coordinate, it was a times y plus k. That was how you get a new y coordinate. So y prime would be 5. A is -2 times y. I don't know what y is. That's what I'm trying to find out. Plus k. K is 1. Now solve for y. Subtract 1 from both sides, and you're going to get 4 is equal to -2y. Divide both sides by -2. Y is equal to -2. This is the original coordinate. And you could double check that if you wanted to, right? How you would check it is, you know that the original coordinate would go to x over b plus h, a times y plus k. So if you took this original coordinate of 4, right, and you said 4 divided by b, 4 divided by a third, that's the same thing as 4 times 3. And then minus 5, so 4 times 3 is 12. And then minus 5 would give you 7. And we would get that answer there. And the same thing would happen here. If you put in your original y coordinate, so this guy, and you multiply it by a, so -2 times 2 is 4, and then you add your k is 1, that would give you the 5. So this is how we go backwards. You're just going to use that formula. You're either your x prime or your y prime. Okay, that takes care of the note packet. So now what I need you to do is open up your workbooks to this lesson in the workbook, which is on page 129. And we're actually going to skip all of it except for the very last example, which is class example number 4. So class example number 4 is on page 132. So go to page 132 and go to class example 4. What we're going to do, and then actually I do one in your homework with you. So we'll do, this will look confusing at first because we're going to be making a new equation here. I'll do one more, like I said, in your homework that's going to be similar to this. So what it says is, it says a graph of the parabola y is equal to x squared plus 1 is shown. So this is a parabola, and the equation of this parabola is y is equal to x squared plus 1. It says the following transformations are applied, and then what it says is in the order shown. What that means is I don't necessarily have to follow SRT. If they say take this parabola and move it to the left first, I just do whatever they're telling me to here. So they're essentially going to do these 4 things. And I just have to follow these 4 in the order shown. So the first one says a horizontal translation 2 units left. You know that that is your h parameter, and h is equal to -2, right? So let's go down here. And for this first one, so this was the first thing, horizontal translation 2 units left. I'm going to rewrite that. H is equal to -2. Then you have to say, what's the replacement? So what was the replacement for H? We're going back to the very first lesson. The replacement for having -2, it's an X replacement. And the replacement was X is replaced with X plus 2. Because remember, when it's an H, it's always the opposite of what it appears. So the equation that we were given was this. Y is equal to X squared plus 1. I'm going to write that equation down. Y is equal to X squared plus 1. Now I have to undergo this transformation here. Take this equation, this parabola, and move it 2 units to the left. So how I write the new equation is it says take out X and put in X plus 2. So this comes out and an X plus 2 goes in. Remember, the X plus 2 has to go in a bracket, the square is on the outside of the bracket. So the new equation would be Y is equal to, so that X comes out, and I'm going to put in an X plus 2. There. So this is the current equation after the parabola moved 2 units to the left. Then it says, this is what it wants to do second, a reflection in the x-axis, right? So a reflection in the x-axis, okay? A reflection in the x-axis would be this. That is a vertical reflection. And you have to say, well, what was the replacement for a vertical reflection? Is it x is going to negative x or y is going to negative y? And the transformation here is y goes to negative y. So whatever this y coordinate was, it's now down here, negative y. Okay, so this is where we currently were. What I have to do is I have to take this out, my current equation, and I've got to input a negative y. So negative y is equal to x plus 2 squared plus 1. Okay, we know we have to divide both sides by negative 1. Before you do that, though, make sure this is in a bracket. Because the y, remember when I divide it over, it's really giving me the a parameter, and the a always goes in front of the entire function. So I'm going to put this whole thing in a bracket. And what I'm going to do is I have to divide this side by negative 1 and this side by negative 1. So if I divide this by negative 1, and I'm going to put in divide by negative 1 in front of the bracket, remember that there's already an invisible 1 there. So now I have y is equal to negative 1, and then this equation here. X plus 2 squared plus 1. Right? Because remember, whenever you have a y replacement, that's going to be an a value. The a value must go in front of the function. If you saw this, you would say that's an a value of negative 1. That's a vertical reflection. Okay, from here, though, I could actually expand and get rid of these two brackets. How you would do that is I'm going to put that negative 1 in front of this x plus 2 squared, and I'm going to multiply it here. So my new current equation will actually be this: negative, and then x plus 2, close bracket squared, negative 1 times 1 is negative 1. That's my current equation. A vertical stretch about the x-axis by a factor of 0.5. So vertical stretch, you have to remember, is an a value. If the stretch factor is 1/2, that means that the a value is 1/2. What that means, if you look at this, the a value, remember, it always has to go in front of your function. I need a 1/2 in front of this function. How do you do that? By replacement notation. It's a y replacement, and the y will lie. So instead of having y is replaced with 1/2 y, it's going to be y is replaced with 2y. So I'm going to, in this equation here, I'm going to take that y out. I'm going to put in a 2y. The reason why I do that is because now I need to divide both sides by 2. And remember that there's already an invisible 1 there. So when I divide this side by 2 and I divide this side by 2, I now have that a value of 1/2. But I could take that a value and I could distribute it in. So that is an a value of 1/2, but now let's distribute it in. So that becomes y is equal to 1/2 times negative 1 is negative 1/2, x plus 2 squared, 1/2 times negative 1 is negative 1/2. We've got one more translation to do. It is a vertical translation 3 units down. That is a k value. K is equal to negative 3. What is the replacement for a k value? Y is replaced with y plus 3. Because if I bring the 3 to the other side of the equation, it would be a negative 3. Okay, so for this here, what we have to do is we have to take out this y, and we have to put in y plus 3. I'm going to take out that y, and I'm going to put in y plus 3. That is equal to this entire thing. So negative 1/2, x plus 2, close bracket squared, minus 1/2. I just have to isolate for y, subtract 3 and subtract 3. Because remember, the k value goes outside of the function at the end. So it's going to be this number, -1/2 minus 3. Just put that over 1 and then get common denominators. So I'll just do that down here. -1/2 minus 3 over 1. I'm going to multiply this by 2, and I'm going to multiply this by 2. That would be -1 minus 6. So that would be -7 over 2. So when you do this, you're going to get -7 over 2. So the final equation is y is equal to -1/2, open bracket, x plus 2, close that bracket squared, minus 7 over 2. This is what you would get if you took that parabola and you applied these 4 transformations in the order given. So again, I think that this one that we just did is going to be the toughest question that we just did. This is one you would want to redo later on, tomorrow when you're studying. We will do one more like this, and then you will see, I forget if it's actually 1 or 2 that I'll do. And you will see, okay, like you'll get the hang of this. It's only one I want to do together. So we'll do number 6 together. So I'll first get you to circle your homework. So I don't want you to actually do question number 2. I want you to do number 3, 5AB, 6, 8, and 9. So get all of that circled. Podcasts that I want you to watch tonight on combinations or combining all the transformations are 8A, 8B, and 8C. And then let's flip to number 6 and do this one together. Actually, if we do number 6, yeah, and then I'll set you guys up for number 8. Okay, so for number 6, this guy here. It's a little bit easier for this one. They didn't actually give me an equation. If they don't give you an equation, they're just going to give you y is equal to f of x, right? But we're still going to be doing the same things. So what it says is the graph of y is equal to f of x. It is reflected in the x-axis. Let's figure out what that is. Reflected in the x-axis, this would go down here. You have to say to yourself, what type of reflection is that? That is a vertical reflection, and that is an A value, right? That means that your y is going to be replaced with -y. So if it's a vertical reflection, y is going to be replaced with -y. Here's my equation. Y is equal to f of x. Draw your arrow and then do the replacement. Take this y out and put in a -y. -y is equal to f of x. You know that y, when you divide this, it has to go in front of the function. So I'm going to put like an invisible 1 there. And I'm going to divide this side by -1 and this side by -1. What I would get now is y is equal to 1 divided by -1 is -f of x. So if the negative is in front of your f of x, that is a vertical reflection. Then it says, so it wants me to do it in this order, vertical stretch by a factor of 3. So vertical stretch, if they want the stretch factor to equal 3, that is an A value. A is equal to 3. We know that the A has to go in front of this function. So I basically need this to become a -3, right? That's what I need. How you do that, though, using replacement notation, is it's going to be another y replacement, and the y will lie. So in order to get a 3 over here, I'm going to replace y with 1/3 y. So this, where I currently am in my equation, I'm going to take that y out, and I'm going to put in 1/3 y is equal to -f of x. I don't want to divide by a third. So what I'm going to actually do is I'm going to do the opposite. I'm going to multiply that by 3, and I'm going to multiply this by 3. What that gives me, 3 times a third is just 1, so my y is by itself. -1 times 3 is -3 f of x. This should make sense, right? Negative is your vertical reflection and 3 is your vertical stretch. So that's been accounted for. But this is just how we do it in replacement notation. And then it says, then translated 4 units to the right. Okay, so let's do this one. 4 units to the right is an h parameter. H is equal to, if it's to the right, it's positive. Okay, so H is positive. That is an X replacement. X is replaced with, in order to get a 4, it would be X minus 4. That would be your replacement. So where my current equation is, I need to take this out and I need to put in an X minus 4. Y is equal to -3f of x minus 4, right? Because if you saw this, you would say, oh, that's your h parameter. H is 4, which is exactly what I need. If h is 4, it's going to the right. The last transformation is this guy right here, 1 unit up. That is a k transformation. K is equal to 1. What was the replacement for a k transformation? It is, or k parameter, it's a y. And y is going to be replaced with, if I want 1, I want this to be a +1, you guys, on the outside of this function. So I want a +1 there. So it's going to be y is replaced with y minus 1. So take this y out and put in a y minus 1 is equal to -3f of x minus 4. Get rid of that -1 by adding 1 to both sides. And this is my equation. Y is equal to -3f x minus 4 plus 1. Okay, so that's my equation right there. And that's it. So I'm just going to stop recording this lesson and then I'll tell you how much time I will give you.